Welcome to my channel. Today we're gonna start chapter 1 rational numbers from class 8 Mylestone mathematics notebooks. Okay, so heading into the video of chapter 1 rational numbers. Several thousands years ago, when there were no numbers, people used symbols, pictures, rocks or sticks to represent numbers. The three very popular number systems of all times are the Egyptian number system, the Greek number system and the Babylonian number system also. Okay, now the Egyptian used some symbols to represent various numbers, like for 1 they used to symbolize it as staff, and for 10 they used to symbolize it as this heel bone. This is called as heel bone. Then they used to call like that. Now for 100 they used this symbol called coil of rope, and for 1000 this is their lotus flower. Okay, they named it as lotus flower. That is a symbol for 1000. Okay, now the Greeks also invented a number system called the alphabet that comprised 600 symbols. Okay, 600 symbols takes a lot of space, right? So the Greeks narrowed down the number of symbols to 22. Some of the Greek symbols are as follows, like these: alpha, beta, gamma and delta. Usually you people see these symbols in your physics textbooks also. Physics and chemistry we use usually in these textbooks, or else in these subjects also. Okay, they are derived from the Greeks only. And the Babylonians used to write on clay tablets that were dried in the sun. Several number of these tablets are still found today, and the writings on these tablets gives us the insights into the Babylonian number system. The Babylonian numbers developed a form of writing based on cuneiform, which means wedge shape. Okay, wedge shape in Latin. Wedge shape in the sense of inverted triangle. Like that they used to write. Okay, this is the introduction of our rational numbers in the Mylestone mathematics textbooks. So, what is a rational number means? A rational number is rational number, rational number, whatever you call in your slang, it's okay. But the thing is, we have to understand the concept here. Okay, so a rational number is defined as a number that is expressed in P by Q form. Okay, that should be in a P by Q form where Q is not equal to 0. Okay, and P and Q are integers. Now what are integers here? In your previous classes you have studied what is integers also. But just for brushing up, I am telling you briefly here. So here counting from 1, 2, 3, 4 and so on comes under natural numbers, which is represented as n. And from 0 onwards, 0, 1, 2, 3, 4, 5 comes under the whole numbers, right? Whole numbers, this is numbers, which is represented as z. Okay, now altogether these numbers, positive and negative integers, also come under the integers, right? So here nowhere it is referred as P by Q form or else rational number. Where did this rational number comes from, right? So that is from P and Q, or integers. P and Q should be integer, means it can be a negative or a positive number, like this. See, 3 by 4 or 2 by 3, which are in P by Q form. Here Q is not equals to 0, means if here 2 by 3 is there, right? If here 2 by 0 is there, means the answer is 2 only, right? 0 doesn't have a value, so it becomes 2. So it is not a P by Q form. It is not a rational number, right? So the Q should not be equals to 0. The condition here is Q is not equals to 0. And P by Q are integers. It can be an integer. It can be a minus value or it can be a positive value. But it has to be in this P by Q form only. The Q should have an integer value, not a 0, right? q is not equals to 0, means q should not be 0 here, means 2 by 0 or 3 by 0 is not a rational number. It becomes a natural number again. If it is minus 2 by 0, for example, for instance, if we take it as minus 2 by 0 here, then what it is? It is a integer again, right? So now we don't write like this 2 by 0 or 3 by 0. We write only like 3 by 4 or 2 by 3, etc. like in this rational numbers. Yes, see, okay. Let's try one, page number 3. Question number 1. Add minus 12 by 11 and minus 17 by 11. So minus 12 by 11 and minus 17 by 11 are the rational numbers here. Okay. Now we are taking the LCM as 11. As we have the denominators same, so we have taken 11 directly. Okay. Now minus 12 minus 17, we are taking them as it is, as the denominator is same here. For both the rational numbers, we have the denominator same. So minus 12 minus 17 is minus 29. You know the addition, right? In previous classes you have studied about this topic. Minus and minus is plus. Okay. Indeed we do the plus, but we have the same sign which we have in the step also. Okay. Now minus 29 by 11. Okay. This is the answer. Now subtract 5 by 8 from minus 9 by 10. Subtract 5 by 8 from minus 9 by 10. Here see, you have to observe here 5 by 8 and minus 9 by 10. Like previous, we don't have the denominator same here. So 8 and 10 gives 80. Okay. Now we are doing the cross multiplication here. 5 tens 50 and we are taking the same sign here over here also. Now 8 nines is 72. So we have the sign minus here. So minus 50 and minus 72 gives minus 122. Okay. Minus 122 upon 80. We have 80 here as we have the LCM of 8 and 10 here. It's not a multiplication actually. We have taken the denominator 8 into 10 is 80. Understood? So this gets cancelled with 2. 2 61s are 2 40s are. So our answer for the subtraction is minus 61 by 40. Let's move on to the next question. And let's try one. So move on to the next topic. Next question. Multiply 0 by 6 into 30 by 46 into 3 by 4. So if you observe the question here, there is 0 by 6, okay, into 30 by 46 into 3 by 4. If we multiply anything with 0, gives 0 only. If you have 0 with your hand and you multiply 1, 2, 3, 4, okay, but you are multiplying it with 0. So the answer will be a 0 itself. But we can't write this in direct step. Okay, if it is a bit, then we can write it as is equal to 0. But for the notebook sake and for our understanding sake, we are extending this into the next step. Okay. Now 0 into 30 into 3. Okay, we are taking the numerators as it is and the denominators like this. Okay. 6 into 46 into 4 upon 0 into 30 into 3. So whichever we multiply with 0, it gives 0. And 0 upon 6 into 46 into 4 also is 0. So the first question answer is 0. Now next question, let's head on to the next question. Divide minus 67 by 19 with 78 by 38. Okay. Now the division rule gives that if it is 1 by 2, what we do? 1 is divided by 2. Then we shall take it as 1 and 2 here. Right? In the same way, we are taking this part here as a P and this part as a Q, P by Q form, right? We know that P by Q means we will write like this only. So in this case also we are doing the same. This is RP and this is RQ. So for division we are taking this like this, the whole part, the whole division part like this, and this whole division numerator in the denominator place. Okay. So our numerator here is minus 67 by 19 upon the denominator 78 by 38. So from this, if we convert this into the multiplication rule, the division becomes a multiplication, right? So the denominator becomes the numerator here. The inverse of this becomes numerator. So here the denominator, if it is inversed, will get a numerator here. So 38 by 78. There is no confusion in this. Simply from the division rule we are taking into the multiplication rule. The multiplication rule. So we have shifted the denominator to the numerator and the numerator to the denominator. Minus 67 by 19 into 38 by 78. So now here the cancellation rule applies. So 19 ones are 19 twos are 38. So it gets cancelled with the 2. 19 twos are. And see here 78 is a multiple of 2. Right? So now it gets cancelled with the 2. 2 ones are 2, 39s are. 2 threes are 6 and 1 gets carried. And 18. Here it will be the 18. Now 3 nines are 18. So 2 ones are 2, 39s are. So our answer is 67 ones are 67 and 1 into 39 is 39. So the answer finally is minus 67 by 39. So now see the fifth question here. Simplify 4 by 10 plus minus of 13 by 15 plus of minus 9 by 50. Okay. Now the solution will be like we have taken all the brackets out and we have taken the minus part outer from the bracket. Okay. Now 4 by 10 minus 13 by 15 minus 9 by 50 after removing the brackets here. So our LCM for 10, 15 and 50 is 150. Okay. Now the tricky part here you have to observe is we are multiplying numerator and in the denominator with 15 because 15 is having a multiple for 150. Right? 15 tens are 150. So we can multiply 10 by 15 to get 150. So we are multiplying this 15 in numerator and also in denominator. The same ways goes with all the other rational numbers. Now 13 by 15 into 10 by 10. Like 10 by 10 in numerator and in denominator. And same goes with 9 by 50 also. 53s are 150. So multiplying in numerator and denominator. Okay. After sorting out all this, we'll get like 60 by 150 minus 130 by 150 minus 27 by 150. Okay. Here everything I have multiplied and taken out the symbols as it is. After simplifying, we'll get 97 minus 97 by 150. Now the sixth question. Which rational number should be subtracted from 6 by 5 to get 6 by 5? A rational number, we remember a rational number is a P by Q form where Q is not equal to 0. But we know that if we subtract any number with 0 will get same number. But in P by Q form, Q should not be 0. That's our rule, right? You remember? So what we do is 6 by 5 minus 0 by 1. We get the LCM of 5 and we'll get the same answer as it is. This is it for the first video of our Mylestone book course 1 rational numbers 8th class textbook. With the next exercise we shall meet you again. Till then, share this video with your friends. Subscribe if you like my content and explanation and give it a thumbs up. Thank you. Bye.